Hello, my name is Jeffrey Taylor, and my science fair experiment was on how heat affects the longevity of a battery. My question was, how effectively do batteries from different companies withstand extreme heat? And my hypothesis was, if the battery is from a name brand such as Duracell or Energizer, then it will withstand heat more effectively. In order to conduct this experiment, you will need 2 AA batteries from Duracell, 2 AA batteries from Energizer, 2 AA batteries from an off-brand, 2 flashlights, 6 hand warmers, a timer, and a thermometer. My dependent variable was the longevity of the battery, my independent variable is the battery brand and temperature, and the controlled variables were the battery's charge when heated, amount of time they're exposed to heat, and the type of flashlight used. To do this experiment, you'll first want to heat up the hand warmers and take their temperature, then place a battery from one brand in between 2 hand warmers for 30 minutes. After being heated, place that battery in a flashlight, then place a second battery from the same brand in another flashlight. Now set a timer. Make sure to record how long it takes for each battery to run out. Repeat this for the other 2 brands. After doing this experiment, these are the results I got. The Duracell batteries both lasted 5 hours, the Energizer that was heated lasted 2.5 hours, the Energizer that was kept at room temperature lasted 3 hours, and the off-brand batteries both lasted 1 hour. Some observations I made were that the Duracell lasted longest both at room temperature and after being heated, while the off-brand batteries did the worst. The average temperature of each heat packet was 57 degrees Celsius and the room temperature was 21 degrees Celsius. There also wasn't a big difference between when each battery was heated versus when it was kept at room temperature. From these observations, we now know the answer to the question, that Duracell batteries are the best option for withstanding heat or even just when being used regularly. The hypothesis was also correct. The batteries that were from name brand companies did significantly better than the off-brand batteries. There are a couple of reasons for the results that we got. One reason that would explain why there wasn't a difference between the batteries that were heated versus the ones that weren't would be that the electrolytes in each battery needed to be exposed to more heat in order to evaporate. All liquids evaporate at different temperatures, so maybe each battery would just need to be exposed to more heat to have more of a difference. There is also a logical reason to explain why Duracell did the best out of all the batteries. They must have had a more efficient electrolyte in their batteries that creates the same amount of power but used less energy from the battery. This information can be important for a couple of reasons. For one, this is useful for someone looking for the best battery for just everyday use, or this could be useful for people who live in more tropical climates and need to know which batteries are best for heat. A more extreme reason this is important is that soldiers stationed in hot climates such as the Middle East might need to heavily rely on batteries, so knowing which batteries work best in heat can be extremely important. So, in conclusion, Duracell is the best battery to use when exposed to both heat and room temperature.